Okay. So let's continue with learn OpenGL. So we left, I was trying to understand the math here. Okay, that's right. We were messing around with changing the camera up position. Because if you have camera up as the Y, I guess what do you call it, the Y vector, then it's about what you'd expect, right? Up is going this way, so your scene is pretty much right side up. If you were to change your up to be the X direction, then it means now your scene is here. So let's say your scene looks like this, something like that, right? Normally up is going this way, so your scene looks how you'd expect it. But if the up is now in the X direction this way, then your scene would be rotated, so it looks, I suppose it would look more like this, right? If that's there, it would look more like this. Something? Question mark? Let's see. Yeah, that's what my guess is. Let's see. Yeah, exactly right. Okay. So if Z is then up, then I would think that you're going, it's kind of hard to draw because it's getting 3D. But if your Z is now up, the up direction, then it's almost like you'd be looking down at the scene, right? So let's do the scene from the side. So let's say we're looking at it. Where's my pen? So this was normally the front, right, going right here, like, if that makes sense. So we have our 2 back here, the 2's on this front, the 1's on that front. So if we're changing it, so now this is our up direction, or I guess, oh, maybe the problem is that we're doing, if we did negative Z, maybe it would work better because, oh no, negative's going this way. Yeah, so we made Z our up, then we'd rotate the entire scene so that Z is now up. Kind of trippy. Rotate so this brain can't understand this. Something like that, maybe? I wish I had like a way to cut and paste and rotate. Is that right? My brain can't really think right now. Yeah, that seems right. But again, this is from the side though. So what does that actually mean? The camera's up this way, which means when our Y is up, then our A key moves us this way. D key moves us this way. W, does W move us forward or back, or what axis is that moving? Oh, that's a bad example because the Z is wrong right now. Yeah, so W moves us forward and backwards, not up and down. So when Y is up, W moves us forward. That's kind of hard to draw in 2D. So when Z is up, our W would move us up and down, right? Our W and S would move us up and down. I guess that'd be A and D, wouldn't it? Right? That's our up, and then we'd move, yeah, X and Y, or sorry, the X direction, the X axis would be our W and S. I don't know, man. Freaking melts my mind. Either way, don't really get, here's what we want to do. We want to just add, so with the Y being the up direction, Our normal scene, sure. What I want to do here is add some keybinds so that I can go up and down. We'll just use shift and space for that. Now we need to figure out the math of this, but shift, we're just going to do this just to make sure the keybind's working. And then we'll change the actual logic to, might need to be L shift, we'll see if that works. You change the logic to actually move it correctly, yeah. GLFW space is not a thing. GLFW key codes. Key space. Oh, duh. Shift may still not work, but we'll see. Yeah. Left shift, yeah. So shift, hitting shift here. Yeah, okay, so those keys are actually bound to doing something cool. But what we actually want to do, figure out the math for this, is our scene is like this. Then our A moves us this way. S moves us this, or D moves us this way. W moves us in. S moves us back. This is along the z-axis. What we'd want up and down. So it should be probably something just related to the up vector, right? Up should be normalized already, so this might work. Speed times camera up, but we want this to be negative instead. Nice, okay, easy. So you want to reverse those, but kind of doesn't matter. So now we have the logic implemented to move in all directions, really. And that'll be helpful for maneuvering around the scene to kind of see. We can't rotate, we don't have mouse input, that's fine. We'll want to see as far as what that looks like when the z-axis is up. I'm trying to figure out if like there's something about it that just makes it not work at all, or if I'm just looking in a portion of the scene that seems like, yeah, so it seems like the scene just doesn't work when the z-axis is down. I don't really understand why. I'm hitting all the keys right now. Seems like my little blocks are nowhere to be found. Interesting. I don't really understand. Why does -1 do anything? We could add some print outputs to print where we are in the scene. Okay, it immediately becomes nan. Interesting. Interesting. Now, why is that the case? Because that probably doesn't happen here. Yeah, we actually do stuff here. Alright, that changes the y value. That makes sense. But for some reason, when the z-axis is the up, we get nan as soon as we try to change. Let me just verify that it happens in any direction. One second. Okay, I had to take care of something real quick. So if I go right, return nan, okay. If I go left, nan. Up, up, okay, W and S are fine. Interestingly enough. Now shift, okay, so A and D cause it to go nan. So let's look into why that might be the case. A and D are doing the normal of the cross product. Is it have something to do with the fact that we're doing a cross product of two lines that are just a direction in the z, or a vector in the z direction? That must be why, because if you do a cross product of those two vectors, 0, 0, -1, 0, 0, 1. Forget the order of this again. Where's that file at? So y times z, so y times z. So 0 yz zy. 0 times 1 plus, minus negative 1 times 0. Z and x. And then x and y, 0, 0, 0, 0. It gives us a 0 vector, I guess. Which I guess is considered not a number. Let's just see what that value is. Vec3. Let's call it the cross. I can't type. So we go left or right. Oh, well, that's going to be an issue if I... So let's not print this out, just so we can see that output. Negative 0, interesting. What's going on there? Why is that negative 0? I don't really know. I don't really know. It doesn't really matter. We can just move on past this and try to keep making progress. I'm curious. Well, we just changed what our front is. I don't really know what's going to happen there, but let's see. Oh, whoa, whoa, whoa! That looks like something, huh? Okay. So what's going on there? I don't know how I got there. Ah, dang. Okay, this is where we want to start putting our position again. So where do we need to be to see our scene? We need to be about 0x. So where do we start? At 3. So we start up here. Man, my brain just cannot process this. We're saying our front is going to be negative x over here. What's going to be there? Where we point? We're going to be focusing on negative x. That's super trippy. I don't know. I don't know. Super trippy. But we do have that, so we'll work with that for now. Here's which update accordingly. If you want to move forward backwards, you subtract. Yeah, that makes sense. Because we're going to use a delta time, yep. Whenever a user renders more frames than another user, he calls process input more often. Oh, okay, that makes sense, because if you're running this loop 30 times per second, you're going to be processing the input only once in a while, but you're moving a constant amount, which means you're going to be moving, say, 30 times that camera speed, whereas delta time will kind of allow for making it proportional based on how long it's been since the last time we called the frames. Therefore, if you're calling it, let me see if I can draw this out. You know, if you're doing this many frames per second, so this many frames happen in a second, then each time you're doing, let's say camera speed is just called x. We'd say okay, plus x plus x plus x. And that's cool. That means in this much time, you'll move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'll move 10x. Right, so let's just call it 10 units. But if you have another computer that's a lot slower, you only have this many frames, you're still moving plus x each one of these iterations, these blocks, but in that same amount of time, the same amount of time here, you're only moving 4 units. But the amount of time that kind of elapses within these blocks, well, of course, for this one, because the block is bigger, the amount of time is bigger. So the delta time here may be, I don't know, there's an arbitrary number. Let's just say it's 4. Of course, it wouldn't be 4 seconds because that's an incredibly slow frame rate, but let's just say. So this distance here, this time here is 4. This time here might be very different, but let's just use the same to make it simple. 4, 4. So what we're doing is saying, okay, let's do, let's actually, instead of doing plus x, let's not do that. Let's do plus x times t. Okay, so this would be 4x, 4x, 4x. And that would mean, oops, that would mean by the end of all this, I'm not sure how the first one works. Let's just assume 4x. I guess technically it'd be right here, 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 and here. So let's just, yeah, let's do it that way. We do have moved 16x. Now over here, let's say this time window is, now it's supposed to be the same. I don't know what the actual math would be. This would have been easier if I used numbers that were divisible by each other instead of 4 and 10. Well, let's just say in here 16 seconds passed. Let's say 16 seconds pass here. So each one, I'm totally guessing here, I'm thinking each one would be, the time would be 1.6, 1.6, 1.6. So each of these would be 1.6x all the way down for each one. Times 10 would be 16x. So what we're doing is we're multiplying the actual camera speed by a different value, in this case a smaller value. So each frame it moves a smaller amount, but because there's more frames it ends up equaling the same. Over here each frame lasts for a longer time, which means the number we're multiplying by is larger. all adds up to the same thing. That's the whole idea with the delta time. And I'm pretty sure at least before there was a way to, whoa. What the heck? Pretty sure before I had a way to like manually change the frame rate. I don't remember how I did that. I'm guessing I calculated the frame rate, or I input the frame rate, right? So let's just say we have our frame rate. Let's just say we want 30 FPS. Suppose that. Let's make it int, obviously. And then we just come up here and essentially can do a continue, I think, if the appropriate time is not passed. What is this? Are these tab sizes different? Guess they are. Should probably fix that. Interesting. Okay. So with 30 FPS, it would mean time per frame, 30 frames per second would be 1 over FPS. So 1 second. My brain is really mush right now. Holy moly. Yeah, something like that. So we need to track how much time has elapsed. If elapsed is greater than or equal to the time we need per frame, or I guess if it's less than, really, because this is a continue check, then we'll just continue. The problem is we don't want to continue because we do need to do some of our stuff, because you'll see this probably will cause an issue. But let's just say elapsed equals, how do you do delta time? I guess they're about to explain that, but I'm trying to do my own thing a little bit. It's kind of doing the same thing, but I'm doing it. I'm using it in a slightly different manner to control the frame rate artificially. How does that work, though? Start at 0, we'd say elapsed equal, we'd say, well, let's say the delta time equals minus the last frame. Does that even make sense? it's less than, we'll do this. Otherwise, we'll say elapsed equals 0. I know I've done this before. That's the funny thing. Must have done it a different way. Because the last frame time is kind of confusing because we're not actually kind of doing something a little different, I think. So elapsed starts at 0 because no time has elapsed. The last time is the starting point of 0. So we'll go, okay, delta time equals the current time minus the previous time. Elapsed has that delta added on top of it to say the overall amount of time since we've drawn last. If the elapse is less than the goal time we want per frame, then we're going to continue. Otherwise, we'd reset our elapse to say, okay, no time has passed. Maybe, I don't really know. I don't think this is going to work. Probably gonna stall out, right? Oh, actually does work. Okay, that's not doing anything at all. It's just my over amount of time. That makes sense, I guess, but why is it? Maybe this is some dumb number because it's not a float. Yeah, because they were both ints. No, guess not. Nope, still not. Okay. Oh man. Delta time equals. So I don't understand what I'm trying to do here. I'm trying to not do any of the drawing stuff unless enough time has passed so that we can kind of simulate a certain frame rate. Oh, you know what? This needs to just be time, maybe? No, still not it. Or not elapsed time, but maybe this needs to be that. Until I have a great handle on this. Okay, maybe we should try writing this out. So we're saying our FPS is 15, which means our desired time per frame will be 1 over 15, which equals 0.0666. Right? Look at cool. Our elapsed, we're starting at 0 because no time has elapsed. We can write it as 0. Our previous time, our last time. Well, this doesn't seem to make a difference, so this might as well be 0, I guess. Our delta time, it's called delta, equals 0. We're going to go through. We're going to say, okay, delta time is actually now going to equal the current time, which is, you know, GLFW get time, minus the previous time. So, for example, if this was, you know, 0.18 or whatever it might be, this might be 0.20, 0.2 minus 0.18 means, hey, the amount of time that's passed since we last did this was, oh, you know what, I don't know. Delta time is 0.02. Cool. Our elapsed is going to have added to it this value. So we're now at 0.02 because it was 0 before. And then we're going to check, hey, is the elapsed time less than the desired time per frame? Yes, it is. So the idea is to, we're not doing any of the drawing stuff, you would think. But this continue statement never gets hit. That's what I don't really understand. We don't seem to ever print continue. Okay, we do eventually. We do up here. Oh, you know what? We're not ever setting last time, are we? That's the problem. Okay. That should probably stall out. Okay, there we go. There we go. So now the frame rate is super jittery because our frame rate's low. We increase this to 60. Should be a little faster, but we'll also be moving faster. Because the thing is, if I hold this down for like a few seconds, 1, 2, 3, we move that much. If I then change this back to 15, and go 1, 2, 3, we clearly don't move nearly as much, which makes sense because that was the thing I was explaining earlier, where we have the whole, you know, the whole frame, like the way I visualize out the frame rate here. Because right now we're moving the same amount. We're moving the same amount in each of these frames. So when the frame rate's higher, we're moving. You know, if this whole thing is 3 seconds, this whole thing is 3 seconds. Again, I explained this earlier, but I'm just redoing, I guess. Then we're moving you know, however many frames there are that we're able to hit in 3 seconds times X. We're over here, it's the same number of frames per second times X. And what we want, again, is to kind of use delta time as part of the equation within the process input. The delta time, the amount of time that has passed since the last frame, should be taken into account when figuring out the amount of movement for the camera. Right? It needs to be multiplied. The delta time needs to be multiplied by the camera speed, which I'm sure is what they were saying over here. Currently, we use a constant value for movement speed when walking around. In theory, this seems fine, but in practice, people's machines have different processing powers, and the result of that is that some people are able to render much more frames than others each second. Whenever a user renders more frames than another, he also calls process input more often. The result is that some people move really fast and some really slow, depending on their setup. When shipping your application, you want to make sure it runs the same on all kinds of hardware. Graphics applications and games usually keep track of a delta time variable that stores the time it took to render the last frame. We then multiply all velocities with this delta time variable value. The result is that when we have a large delta time in a frame, the movements, right, it's going to say the movement speed is larger. The velocity for that frame will also be a bit higher to balance it out. Using this approach, it does not matter if you have a very fast or slow PC, the velocity of the camera will be balanced out accordingly, so each user will have the same experience. To calculate delta time, we keep track of 2 global variables, kind of doing, I assume, similar things that I did. How much time has passed since the last frame, and then last frame time. Within each frame, we calculate the new delta time. So we'd say current time is this. Yeah, exactly what I did. I wasn't referencing this. Pretty much exactly, right? My only difference is I'm using this elapsed thing to then calculate, to kind of simulate the specified frame rate. So instead of having this here, current time can stay there because we're just using that as kind of a temp variable, but those go up there. And now that delta time is a global, we can then say times delta time. And let's just do the W key, because then we'll be able to see the difference here. Last time. Well, I don't know if that'll even work. So we're moving super slow. Okay, W is actually not doing anything at all. Oh, we're just doing camera speed, I guess. I guess that's fair. I was doing the math wrong. So everything but the W is still the super. Oh, see, now I'm stalling out. Interesting. Why is that stalling out now? Look at that. The thing is, I want to be able to simulate this. So how would you do that without this? What's the difference here, even here? This shouldn't make a difference, right? Okay, so we're still moving here. Cool. Oh, we probably just need to increase the speed. Maybe? Because they changed it to 2.5. Perhaps. No, it just doesn't work now. Interesting. So if we... The problem is we're probably hitting this process input so rarely. It's causing some issues. Probably hitting it never. But why are we hitting it never? Why does that work? Huh. You're telling me it works if we don't do that? That's strange. Okay, so we can move when we do this. That feels really strange, doesn't it? Okay, process input is getting printed. It's just... So we're processing that probably 15 times per second, which is what we want. Yet why, if we change this up here, delta time must not be getting updated. But it is getting updated. It's getting updated right here. Super small value. Sure. So what's 3.8 times 10 to the -6 super small value times 2.5 is going to be an also super small value. The frame rate's so low that we need the movement speed to be higher, I guess. Now let's do like, I mean, I don't know, like okay, there we go. So then, whoa. Oh, sure. Only one of those actually uses that. Oh, so the camera speed works fine like this, but if I hit W, whoa. I actually don't know what's happening there. I wasn't hitting W, I was going backwards. And it just spazzed the fuck out. W works fine. It kind of jumps around though, doesn't it? Yeah, what's happening there? Oh, I didn't. No, yeah, I didn't do anything W. That's right. Interesting. So what if I change that frame rate to be 60? See, See, it's doing this huge jump thing. Super weird. Maybe every time this continue gets hit, we're like not drawing stuff or something. I don't. Let's see if it just flickers without me moving around at all. I guess not. See? Okay. See, that's incredibly weird. Let's see if we can, let's print out the position. Seem to be weird. Yet we're all of a sudden jumping. See right? Oh, there's like a freaking window for. Yeah, I don't really understand what's happening. It's super jittery. Like, why are we just jumping back by 20? It must have to do with the fact that maybe something accumulates differently when we hit this or don't hit this. Let's see if, I mean, this seems to be the same logic. Let's just do this, see if it does the same thing. So we want to poll events regardless, I guess. We already have delta time. Now minus last update time. Last frame time. Kind of like that phrasing more. Last update time. Okay. If now minus last. Wait, do they have? Oh, they have both. Number of seconds since the last loop. Oh, they have both. Okay, interesting. Let's just do it all global and we can figure that out from there. Time, number of seconds since last loop. Okay. So if now minus the last frame from the time, number of seconds since last frame, or see, that's not FPS limit. Frame. This is not. This is confusing because it's not frames per second. 60 is the frames per second, but 1/60 is seconds per frame. There's something wrong with this. Because, okay, let's see what we're doing here. We're grabbing the current time, sure, saying that the time between update your application logic here. So this stuff should actually go on the bottom of everything. If we change this to be something far more reasonable, does that work? Okay, sure. But then why the heck was my thing being all weird? What's the difference? So we don't need elapsed. Okay, that's not even... Oh, that's not even changing the frame rate though. That didn't change the frame rate at all. Oh, probably because this... Does this need to go at the end? Maybe because that's being done regardless. Okay, there's 15 FPS. So that might have been part of my issue, but what we're saying is, okay, we're going to grab the current time. The time passed between the last update time and now is the delta time. We're going to pull for events. And then we're going to say, hey, if the current time minus, if the time elapsed between the last frame and now is greater than or equal to 2 seconds per frame, okay, we're overdue, or we're due for a new frame. So let's swap the buffers and show that frame. And then set that last frame time to say, hey, we just now did this last frame. Last update time is the amount of time for the entire loop, regardless of if we updated the frame or not. So delta time is just the amount of time since we last ran this loop and hit this code, right? So the amount of time elapsed through all of this, and now we're back here. Okay, how's it different from mine? I'm saying we're grab the current time, or now. We're saying, hey, our last frame time, which was confusing because that was a different, potentially different thing. Because all we did was update elapsed. Every time we said last frame time is current time, which might have been caused things to be off just a little bit. Because we didn't have our update time after swap buffers. Maybe that was the issue, I don't know. Either way, this now works. And there's no weirdness. It's just a super slow frame rate. Cool. Dope as hell. Yes, we can move around the scene. Awesome. And now the next step after this will be apparently digging into this math of how mouse movement works.